Hello. Our objective in this video is for you to be able to calculate the relative abundance of two isotopes when given the relative atomic masses of a specific element. So let's get on with it. In a previous video, we had learned how to calculate relative atomic masses. So we said we have these two isotopes, and we know that a sample of boron there must contain both of these isotopes if it's a naturally occurring sample. So what we can do is we can use a mass spectrometer to measure the relative abundances of each of these two isotopes of boron. And we get a readout like that, which tells us that 19.8% of the boron in that sample is boron 10 and 80.2% is boron 11. And so now we have the relative abundances of each type of boron, and we can just use this basic mechanism. We multiply the relative abundances by the mass numbers. We add them together to find the relative atomic mass, which is a weighted average. So we have here 0.198, which is 19.8%, which means just move the decimal place back 2 places. Okay, so 0.198 times 10 plus 0.802 times 11. We do the math and we get out a nice answer of 10.802. So that's all nice and easy. That's elementary school math. Now we're going to move on to middle school math by flipping the problem. So here, what we're used to doing is we're given the abundance and we're asked to calculate the relative atomic mass. Now what we need to do instead is, given the relative atomic mass, calculate the abundance. So let's look at that kind of a problem. We'll be given a sample of boron, well, not really a sample, we'll just be given a piece of paper and told that a mole of boron weighs 10.802 grams. What is the percentage composition of isotopes boron 10 and boron 11, knowing that boron contains only those two isotopes? To understand this, let's look at an analogy. So in the previous video, I had given you this analogy with the basketball players. Let's look at it again. So we have a team of basketball players, 10 of them. We have 9 of them are really tall at 2 meters, and 1 of them is quite short there at 1 meter. And we asked, what's the average height of this basketball team? It wouldn't be 1.5 meters, right? That would just be the average height of 2 of them. So we need to reflect the rest of them. And to do that, we multiply the abundance by the heights and then add. So we have 0.9 or 9 over 10 times 2 plus 0.1 or 1 over 10 times 1. And we get out a final answer of 1.9. Now let's modify the problem. Let's flip the problem just like we did with the boron. So here's a new type of problem. We have a team of basketball players of 2 heights, 2 meters and 1 meter, and we know the average height is 1.9 meters. What proportion are 2 meters and what proportion are 1 meter? So imagine now that we didn't know the proportions. We just knew that there were 2 types of basketball players. One type is 2 meters tall, and the other type is 1 meter tall, and we were given the average. And we're asked, what proportion is this and what proportion is this? Well, just by looking at the 1.9 meters, you can see it's closer to the 2 meters than it is to the 1 meter. So there must be more of the 2 meter guys than the 1 meter. But exactly how much more? Let's see how we can use some mathematics to figure this out. What we're going to do is we're going to leave the old problem that we're used to. But imagine that we didn't know these proportions, the 0.9 and the 0.1. Just close your eyes, imagine we didn't know that. And let's see if we can find them using some simple mathematics. So what we're going to do is, just like we did before, we multiply the abundances by the heights and then add. What are the abundances though? So what proportion of the basketball team is 2 meters tall? We don't know. So what do? We do what we do in algebra, is we call an unknown, we call it x. So we have x here, we don't know what that value is, times the height of those players. So x times 2. We already know that it's 0.9, but imagine we didn't know, we would just call it x times 2. Okay? Plus, proportion is 1 meter tall, we also don't know. So what do we call it? We could call it maybe y, but no, we can do better than that. We can call it 1 minus x. Why? Because, well, sorry. I just thought that was funny. Well, because x and y must add up to 1, right? If we know that there are only 2 types of folks in the basketball team, then the proportion of one plus the proportion of the other must be equal to 1. Therefore, we can just put 1 minus x here. So 1 minus x times the height of those players, which is 1. And we know already what the weighted average will be, 1.9, because it was given to us in the question. So now we just do the math. Now this is the middle school math problem. So we have 2 times x gives us 2x, 2x there. Plus here, we need to multiply 1 times 1, which will give us what? 1. And 1 times minus x gives us minus 1x. And that's equal to 1.9. What do we do next? Well, we can subtract 1 from both sides, right? And so we move that 1 over to this side, subtracting 1 from both sides. Here we're left with 2x minus 1x, which gives us x. And here we're left with 1.9 minus 1, which gives us 0.9. And now we found this x value of 0.9, which we were pretending not to know. Do you see the beauty of it? So just simply knowing that there are 2 types, and we know the final weighted average, we can calculate what the proportion of each type is. Let's go back to boron. A mole of boron weighs 10.802 grams. What is the percentage composition of the isotopes boron 10 and boron 11? We're going to do exactly what we did with the basketball players. So we're going to multiply the proportions by the masses and then add. But we don't know the proportions. That's okay, we're going to find them. So what proportion is boron 10? We don't know. We just call it x. And we say x times 10 plus what proportion is going to be boron 11? We also don't know. We call it 1 minus x. Why? Because we know that that and that must give us 1. And we multiply that by 11, okay? Because that's the mass number. And we already know the final weighted average, or the relative atomic mass, of 10.802. And now we do the middle school math problem. 10 times x is 10x, all right? And then 11 times 1 is what? 11. 11 times minus x is minus 11x, is equal to 10.802. We move this 11 over to the other side. This is plus 11, so we subtract 11 from both sides, and we have minus 11 there. And now we have what? Minus x is equal to, if you plug this into your calculator, you get minus 0.198. They're both negative, which is kind of yucky. We can just get rid of the negatives, because we're doing the same thing to both sides. And we have a final proportion of for boron 10 of 19.8%. That's just this thing here as a percent form. So you just take the decimal place and move it 2 places forward, 19.8%. And how about for boron 11? Well, it's going to be 100% minus 19.8%, which is 80.2%, which of course was what we were given in the beginning. So pause the video and note the relationship between what we're doing here and what we're doing here, which are flip sides of the same problem. Here, we are given the relative abundances, and we use those to calculate the relative atomic mass. There, we were given the relative atomic mass, and we don't know the relative abundances, so we just call them x and 1 minus x, and we use those in the end to find these relative abundances. The 0.198 here, all right, and the 0.802, which is just 1 minus 0.198. Pause the video and process this. When you're done with that, let's move on now to another question. A sample of copper consists of copper 63 and copper 65 with an average mass of that stuff. AMU stands for atomic mass units, by the way. What is the percentage composition of copper in terms of these 2 isotopes? Pause the video, think of how you would work this. Here's the idea. We're going to multiply the proportions by the masses and then add, just like we've always done. So here we have, what is the proportion of copper? Well, we don't know. We just call it x. And we multiply that by the mass number. What proportion is copper 65? Sorry, I said what proportion is copper. I meant what proportion is copper 63. Here, what proportion is copper 65 is 1 minus x. And we multiply that by 65. Let me very quickly explain this x1 minus x thing, because maybe some of you are a bit lost. So we know that there are only 2 types, which means the proportion of them must be equal to what? 1. Right? It would be like if you had, I don't know, if you had a pizza and you knew that, let's say half, no, let's not say half. Let's say you knew that 75% of it was pepperoni. And I asked you what percent of it is left. What percentage is, I don't know, margarita. So here we know this is pepperoni. And I ask you what percentage is margarita. Well, if this is 75%, we know 0.75 plus whatever this stuff is, let's just call it y, must be equal to 1, right? Because we have 1 whole pizza there. And then for y, must be equal to If we subtract 0.75 from both sides, we have 1 minus 0.75. Okay? If we didn't know this, we would just call it x, and so it'll be 1 minus x. So hopefully you see now how y is 1 minus x. That's kind of messy. But you can see that this has to be 1 minus x if there are only two types. Okay, let's move on. So now we do the middle school math problem. 63 times x is 63x. 65 times 1 is 65. Minus x times 65 is minus 65x. And we just bring that down. And then we subtract 65 from both sides. So we end up with 63x minus 65x on this side. And 63.546 minus 65 on that side. And what does this give us? This gives us minus 2x. What does that give us? Minus 1.454. You can get that from your calculator. These are negative numbers. We can change the sign by dividing both sides by what? Minus 1. All right? So the minus will cancel the minus. And then we divide both sides by 2. And that will give us divide both sides by 2 like this. Okay? And that will give us here 0.727. We convert that to a percentage. And we're given then that the proportion as a percentage of copper 63 is 72.7%. And for the other one, we just subtract that value from 100. Okay? One last problem. Again, make sure you pause. If you didn't pause the last one, it's your last chance. Okay? Practice is the best teacher. So pause the video and try this one. Naturally occurring chlorine consists of chlorine 35 and chlorine 37 with an average mass of 35.45 atomic mass units. Show that chlorine 35 is the more abundant isotope. This is just a fancy way of saying calculate the relative abundances. So again, pause the video and try it. In 3 seconds, I walk through it. 1, 2, 3. Here's the idea. Just as always, we multiply the proportions, which are unknowns, by the masses, and we add them. This proportion is an unknown, x times 35, plus this proportion unknown, 1 minus x, since there are only two of them, so they must add up to 1. 1 minus x times 37 is equal to 35.45 atomic mass unit, and we just multiply it out. Here we have 35x. 37 times 1 is 37. 37 times minus x is minus 37x. 35.45 there. We subtract 37 from both sides. Beautiful. And we're left on this side now with minus 2x is equal to, on that side, minus 1.55. We divide by the minus 1. We divide by 2. And we have a final answer of chlorine 35 being 77.5%. So we have shown that it is indeed the more abundant isotope. And chlorine 37 is 100 minus 77.5%, which is 22.5%. And you should be able to just look at the question. Like, if you look at these two, chlorine 35 and chlorine 37, and you see the average mass is 35.5, you see that's so much closer to this one. So intuitively, you should see that this guy, so here we have 35, and here we have 37, and that guy, 35.45, is somewhere like here. So you should see that this one has a higher weight. It's pulling further in that direction than we're pulling in this direction. But the question is, what is the precise value? And that's the, my microphone. And that's the mathematics we just did there. Okay, I think we have covered this objective. I can calculate the relative abundance of two isotopes when given the relative atomic mass of the element. You might need some practice on this, of course. With mathematics, practice is the best teacher. So I'll let you do that, and I will wish you good luck. Bye-bye.